You know, have you ever just stopped to think about the absolute avalanche of data we all deal with every single day? I mean, from the moment your phone starts buzzing in the morning to a simple trip to the grocery store, information is just constantly being created, moved around, and logged. It's this incredible, non-stop digital river.
So that begs the question, right? How on earth do organizations manage all of that? How do they take that absolute chaos of information and somehow wrangle it into a powerful, genuinely useful tool? Well, the answer is this invisible engine that's quietly powering pretty much our entire modern world, the Database Management System, or, as you'll hear it called, the DBMS.
All right, so to really get our heads around what a database is, we're going to break it down into 5 key parts. First, we'll tackle that data avalanche. Then, we'll look at the anatomy of a database, peel back its layers of complexity, understand its core jobs, and finally, learn the language we use to talk to it, which is called SQL.
So let's dive right in. What exactly is a database management system? Let's cut through all the technical jargon and get right to the heart of it.
Okay, so a DBMS is way more than just a digital filing cabinet. The magic words here are logically related data. That's the secret sauce. It means the system isn't just a dumb storage bucket, it's actively defining, structuring, and protecting the information inside it. And that's what turns a giant, messy data dump into a powerful, organized tool that you can actually use.
Now, to really understand how a DBMS works, you've got to look at all its moving parts. And that doesn't just mean the technology. It also includes the people who bring it all to life. So let's check out the basic anatomy of a database system. You can pretty much think of any database system as having 4 main pillars. First, you've got the data itself. Then you've got the users who need to get to that data. Of course, you need the physical hardware for it all to live on. And finally, the software, the DBMS itself that makes it all work together. So who are these users? Well, on the front lines, you've got your end users. Think about an airline agent booking your flight. They're an end user. They're using an application that was built by application developers. Then, behind the scenes, you have the database administrators, or DBAs. These are the guardians, the people who design, manage, and protect the database. And then, at the deepest level, you might even have database programmers who are actually building the DBMS software itself. Next up, the data. And you know, it actually comes into really important flavors. First, there's the operational data. This is the day-to-day stuff, right? Customer names, sales figures, inventory counts. But just as important is the metadata. Think of this as data about the data. It's the instruction manual that tells the system things like, hey, this field has to be a date, or this one can only be a number between 1 and 10. It's the metadata that gives all that chaotic operational data its structure.
So how in the world do you manage all this complexity? Well, one of the most brilliant ideas in all of computer science is something called abstraction. And the best way to think about it is like peeling back the layers of an onion. It's just a really clever way to separate out the different ways of looking at the very same data.
It all works on 3 different levels. So at the very top, you've got the external level. This is what a specific user sees. The sales team, they only need to see customer orders. The warehouse team, they just need to see stock levels. Simple. Below that, you've got the conceptual level. This is the architect's master blueprint for the entire logical structure of the whole database. And then way down at the bottom is the internal level. This is the nitty-gritty physics of how the ones and zeros are actually physically stored on a spinning disk or a solid-state drive. This separation is absolute genius because it gives the whole system incredible flexibility. You can change how the data is stored physically without breaking the apps the users see.
Okay, so we've seen the parts and we've peeled back the layers, but what does a DBMS actually do? I mean, what are its most important jobs day to day? This is where the real power starts to show.
At its very heart, a DBMS is a master multitasker. I mean, sure, it stores, retrieves, and updates data, but beyond that, it's juggling all these incredibly complex jobs, like managing thousands of users at once, recovering instantly from crashes, enforcing security rules, and making sure that critical business transactions never ever fail halfway through.
Let's just take one of its most critical jobs, concurrency control. I want you to imagine a website selling tickets to the hottest concert of the year. The second they go on sale, thousands of people slam that buy button at the exact same time. The DBMS is the digital traffic cop that makes sure 2 different people can't buy the exact same last ticket at the exact same millisecond. That's concurrency control, and without it, e-commerce would be total chaos.
But, of course, a system this powerful has its trade-offs. The advantages are huge, right? You get to control redundant data, you can make sure your data is always consistent, and sharing it becomes way easier. But the downsides? Well, these systems are incredibly complex. They're expensive to buy, expensive to run, and you need skilled people to manage them. And because everything depends on this central system, if it fails, the impact can be absolutely catastrophic. It's a constant balancing act between immense power and some very real-world costs and risks.
Okay, so we've got this powerful, complex engine humming away. But how do we actually tell it what to do? You know, how do we ask it for a piece of information or tell it to store something new? That's where database languages come into the picture.
Generally, these languages fall into three main categories. And here's a good way to think about it. The DDL, or Data Definition Language, is like the architect. It's the language you use to build the database's skeleton. The DML, Data Manipulation Language, is like the worker. It puts data in, takes it out, and makes changes. And finally, the DCL, Data Control Language, is the security guard. It manages who gets the keys to which parts of the database.
And in the world of relational databases, which is most of them, one language is absolute king, SQL, which stands for Structured Query Language. It is the undisputed industry standard. It's the lingua franca for talking to data.
Now here is the real magic of SQL. It's what we call a declarative language. And what that means is you simply tell the database what you want, not how to get it. You just say, hey, get me a list of all the customers in California. And the DBMS itself figures out the fastest, most efficient way to dig through all the data and bring that list back to you. You don't have to write out the step-by-step instructions. That simple idea is what makes it so unbelievably powerful. So what does this look like in the real world? Well, here's a classic, simple example. We're just telling the database, I want to insert a new record into the book table. For the title, put in Hocus Pocus, and for the price, put in $5.99. See, it's pretty straightforward.
If you break it down, it's structured a lot like a simple sentence. You have reserved words, the commands the database already understands, like insert into. You have user-defined words. These are the names you've created for things like book for the table name or b_title for a column. And then you have the literals, the actual data itself, like the text Hocus Pocus. You just combine these pieces to form a clear, logical instruction.
So as we wrap things up here, it becomes really clear that these systems are truly the invisible scaffolding of our modern lives. From the second you check your bank balance in the morning, to booking a flight, to just scrolling through your social media feed, you are constantly, and I mean constantly, interacting with a database management system. They are the unsung heroes that turn these massive, unmanageable oceans of data into the seamless digital experiences that we all rely on every single day. So here's a little challenge for you. For the rest of the day as you're going about your business, try to spot that invisible layer. The next time you stream a song, or buy something online, or make a reservation, just take a second and remember that there's a powerful database engine working tirelessly behind the curtain, managing all that information just to make it all possible.